Hello everyone, welcome back to Python course. In the previous video, we have learned one of the most important programming concept called functions. We saw how functions help us to write code once and reuse it whenever we need it. They made our program shorter, cleaner, and much easier to maintain. Today, we are going to learn another important fundamental concept that every programmer use almost every day. We are going to learn list and tuples. Until now, our variables could store only one value at a time. For example, name equals to Alice or age equals to 28. One variable, one value. But what if we want to store marks of entire class or all products in the shopping cart or just 100 numbers of students? Creating one variable for each would be very difficult, or you can say impossible. That where Python collections come in. Collections always allows us to store as many values in a single variable. By the end of this lesson, you will be able to create lists, access elements, modify them, use full list methods, understand tuples, and know how to choose tuples or a list. So let's begin. Before we start coding, let's quickly revise what we are going to learn today. Today, our lesson is majorly divided into three main categories. The first section contains list fundamentals. We will understand why collections are needed, why is list actually, what is list actually is, how to create list, how indexing works. In the second section, we will learn about working with list. We will learn slicing, updating values, important list methods, and even nested lists. And finally, we will move to tuples. We will understand what tuples are, their operations, how they differ from list, and we will finish with practical programs, practice questions, and a complete revision. By the end of today's lecture, you will be able to comfortably work with Python's two most commonly used collections types. So before learning list, what a list is, let's understand why collections are introduced in programming. Imagine you are writing a shopping application. Without collection, your code would look like item 1 milk, item 2 eggs, item 3 bread, item 4 butter. This works. But what if the consumer buys 10 items, 50 items, or even 1,000 items? You will end up creating each variables for each one. Managing them creating is almost impossible. Searching, updating, or even deleting items become difficult. Your programs become messy and hard to maintain. Now look at the same problem using a list. Shopping list, milk, egg, butter. As you can see this in this side. Instead of four variables, we are using only one variable. Instead that one variable, we will store four different values. If tomorrow we want to add another product, we can simply add it to the list. The code remains clean, organized, and easy to understand. That's why collections are very useful. So collections are everywhere in our real life. Look at the example shown on the slide. A shopping cart stores many products, and an attendance register. A contact list stores multiple phone numbers. A music playlist stores multiple songs. In every one of the examples, you can see how multiple related values are stored together. Python lists solve exactly this problem. Instead of creating many variables, we store everything inside one collection. Now, let's define what a list is. So a list is a ordered mutable collections that stores multiple value into a square bracket. That's sound technical. Let's understand in very easy words. The first word is ordered. Ordered means every item kept its position. So basically this means that if I have defined here 10, 20, and 30, so basically its location will not change. 10 will be always be at first position, 20 will be second, 30 will be third, and 40 will be at fourth. Python remembers their order, and the position do not change unless we change them ourselves. The second is mutable. Mutable means unlike some other data types, list allows to modify their contents. Means we can add or remove the previous or even replace with new values. We will practice this soon. Don't worry. Then the another is key feature is duplication. So basically duplication means we can store same value data value multiple times. This duplicate data is completely normal. For example, multiple students score may same marks. Finally, list can store mixed data types. For example, list can store integer, float, boolean, and everything in the same collections. The flexibility makes lists extremely useful. Now, creating list in Python. Let's understand how to create list. Creating a list is very simple. We use square brackets, place the elements inside, and separate them using comma. Let's see with an example in the VS Code, means coding platform. So here, numbers equals to square bracket 1 comma 2 comma 3. Now this creates a list of integer. Now let's create a list of strings. So for that, names equals to square bracket John Emma. Here both elements are strings. Next, let's create a mixed data type. Like we will go with mixed integer, string, and boolean. Now notice how one list stores three completely different data types. Finally, we will also create an empty list. Empty equals to square bracket. An empty list contains no elements. We will often create an empty list first and later add the items one by one. So let's verify each one of them. Going with print numbers, print mixed, print name, print empty, print type mixed. Now see what the output becomes. Notice how the last output clearly tells us then that mix is list. Whenever we are unsure about variables, we can use the type function for checking its data type. Before moving to the next topic, let's quickly revise this. So till to now we have learned how why collections needed. We learned that list stores multiple values inside one variable. We understood that lists are ordered, mutable, and allow duplicate values and can store different types of data. And finally, we learned how to create different kinds of lists in Python. Now it's time to actually work with data stored inside a list. So imagine you are doing a shopping list with 20 items. How do you access first element or the last element? What if you want to store something in the middle, or there something you want to change in the list? That's exactly what we are going to learn. We will cover four more important topics: indexing, negative indexing, list slicing, and updating lists. So for that we will starting with how to creating list and how do we access individual element. Python uses something called indexing. Think of a list like a row of lockers. Every locker has a number. Instead of searching every lockers, can simply check the number for the locker you need. Python works exactly the same way. So basically, let me show you in the coding platform. Fruits equals to apple, banana, and then orange. Noting something important. Although there are three items. Their indexes are 0, 1, and 2. 0, 1, and 2. Indexing starts from 0, not 1. This is called zero-based indexing. Almost every programming language follow the same rule. Now we'll access the first element. So for that, print fruits using square bracket and 0. We can access the first element as indexing 0, and you can see apple being printed. We can also access the second element the similar way, just changing the value inside and running it. You can see banana. And when we will do with, let me show you the same thing. You can see, oh, sorry, two. You can see all three are being printed. Now let's understand that the numbers inside the brackets are what it tells us which value will be going to be printed. And here's something beginner often do. Suppose we write fruits equals to 5. This will cause an error because list error named list index out of range or index error. Basically this means that the index that we are searching does not exist. Now let's move to negative indexing. So far we have counted from the beginning, but what if we want last element? Normally we don't need the last element. Python gives us the easier solution. It allows us to access elements from the last. So for that we need to do this. So for accessing from last, we need to start from -3, -2, and -1. Basically, where here 0 is not used because if I will use 0, then it will be counted in forward. Notice here the last elements is always -2, second last so last -1, second last -2, and third last is -3. It's extremely useful, especially when we don't have the knowledge that how many elements are present. So basically, we can do from the last one. Negative index is also widely used in real world problems, especially when we are working with files, strings, or large data sets. Here an important trick to remember. Positive indexes move from left to right and negative indexing moves from right to left. If you remember this, indexing becomes very easy. Now let's talk about list slicing. So list slicing is basically, suppose we want a group of elements. That's where the slicing comes in. Slicing allows us to access a part of elements. So the basic syntax is basically like here you can see list, start, stop, and step. And stop here, not stop is exclusive, not included. So basically, if you will type same with like lists, sorry, same like loops, that's the last element is not accessed. But remember, stop indexing. This is one of the most important tool. Finally, step tells us how many steps we need to jump. So let me show you with the coding. Nums equals to, you can see, now let's access print nums 1 colon till 4 and just run it. You can see from 0, 1, 2, 3, 4. So I am using till 1 to 4, see 1 to 4. And notice that so 50 is not included as it we have stopped till 1 to 4 only. We can also do like this. If we will not put any value at the beginning, it will automatically take from beginning to where we have stopped, or the opposite way also works, from 20 till 50. You can see. We can also do it like this for indexing. Using the step block, we can also go from the opposite, like printing it in the reverse manner. This is the easiest way to reverse by just using the minus. Now talking about updating lists. Now let's see why lists are called mutable. Mutable means we can change them after they have been created. Now look at the example. Here, here numbers are 10, 20, 30, 40, and 50. Now our list looks like this, and suppose we want to replace 20 with 99. So for that we need to simply just do nums and the space where we want to change, which is 1. So 1 equals to 99. And when we will print again, it will be get updated. As you can see, the value of the value at the second position means the first index is changed. Now new lists are created. The original list only change itself, means no new list is just the value gets updated. This is called mutable. And now let's add an element. So for that we can do nums dot append, and we will add a value 60 and clicking on run, and reprinting. For that we need, you can see the new value is being updated as 60. We will learn append is much more detailed in the next lesson. For now, just remember what it's just add the element. And suppose we want to delete, so for delete also we will need to go like this, del num and the position where we want to delete. I will go with 5. For that, let me show you. See, again the 60 is being deleted. Not, and if we will think, if we will delete 3 also, 3, and run, you can see how the remaining list have shifted from right, left is from right to left, as it fills empty spaces by itself. This is one of the biggest advantage of list. We can change elements, add new element, remove existing one, all without completely creating a new list. That's called mutable collection. Now let's say, as we have done with the slicing part, now let's see Python's provides the built-in methods that allow us to add, edit, slice, search, sort, and manage list without just one line of code. Instead of writing long programs, we can simply use this method. Today we will learn some important list methods that programmers often use. So for that, we will first go through adding more elements using append, insert, and extend, and all three adds data. And let's understand each one. So for the first one, going with the append. Here basically we can seen the use, we have seen the use of append. So append basically does what, it's changes the original list, means no new list is created, and the original list is being edited, and the new value, that is 60, is being added at the last. Even if we will add anything, like even we will add, if we will add 23, it will still being added at the last only, because using append, we all the value that we will inserting is at the last. Now talking about insert. So for insert, nums dot insert, and insert is 1 comma 2, and then print nums. So basically, what does this insert do? Insert do index based insertion. So basically, it shifts all the elements at the position 1, and there 2 is being inserted. So basically, all elements are being pushed to the right side, and the 2 is being inserted. Then next comes extend. Extend, instead of adding one item, we can add multiple items using extend. So extend is basically, you can see, for here, for let's print once before, then it's more easy. So basically, you can see we have created a list with a value 1, and we have inserted 2 and 3 later on using extend. Extends it that much only. Now moving to learning how to remove items from a list. So items can be removed from the list using either remove, pop, or clear. So each one serves different purpose. So starting with the remove, for remove we can just go with nums dot remove, uh, 2 we will go with, and again print nums. Clicking on run, you can see the value 2 is being deleted using the remove. So it's just remove the value and update the list, and we have just used the value to remove the we have just used remove to remove a value, because it's mainly used when multiple value appear same time. We just want it to related, and think it like this: we have two multiple tabs, but only the 2 that comes first will get deleted, means the first occurrence is being removed here. Now talking about pop. So pop basically, nums equals to 10, comma 20, comma 30, value equals to nums dot pop print oh, print value print now. Clicking on run. I noticed something interesting. We didn't provided any index. When no index is given, pop removes the last element. The removed value here 30 is being stored inside the variable inside the variable value, and the remaining list becomes same as it is. So one important difference is remove simply deletes and pop deletes and return the removed value. That's it you will see often when you are writing programs. Now talking about nums dot clear and then print nums. So basically, dot clear completely removes all the elements inside the lists, and it's completely empty is the lists. Now some utility methods that we are going to explore. So for that we will go with first sort. For that we need nums equals to 4 comma 2 comma 6 comma 7 9 8 and after that nums dot sort print sort no print nums. As names only suggest that in this the value got sorted in the ascending orders and the ascending order value is being printed. Now talking about nums dot reverse nums dot reverse just reverse the values means the ascending order is just flipped to the descending one. Then we will go with nums dot count to yeah we need to print it print. So basically, the count is here. The value inside the count will be counted. Number of times it is being appeared on the list is being counted. You can do see this using this clicking or run. You can see it's become 2 now, as there are 2 occurrence of 2 in the lists. Now talking about 0 1. Here basically we are using index. Index returns the first occurrence of the value. So basically we are searching for 6 here. So 0 1 2, and at the second occurrence the 6 is there, so it's just print 6. We can check it using see. So 9 is the first occurrence, so 9 becomes 0, so it's 0. Now There is another new num equals to nums dot copy and clicking on a printing print a new num. Now just run. We will run, when we will run it. You can see the list is being assigned without changing anything to the new variable. And then there comes sort and sorted. So for sort and sorted, let's compare them quickly. So sort basically does print nums. Click on one. And now doing with the result, it was to sorted, which is nums, and at the last print result. You may think that it will be edited after this, but it's not working. So just click on that. So you can see that the new sorted list is being sorted. So basically, sort change the original list, and sorted change the list to sorted version in the new variable. This small difference makes it important for professional programming. Now we have done with append, insert, extend, remove, pop, clear, sort, reverse, count, index, copy, sort, and sorted. Yeah. And now it's a time to perform some real works with list. Suppose we have list containing 100 names. Do you want to really print it like print students 0, 1, 2, 3 means using indexing? Of course not. We are not going to do. So for that we are going to use loops. We will use nested list which will help us to store data like table. Finally, we will begin with learning another important called collection. So for that, starting with one of the biggest advantage of list is that we can process every element automatically using a loop. So let's look at our first example using roots equals to apple, comma, banana, comma, cherry for item in root print item. So basically, we are iterating through the list, printing one value at a time. So it start the list during the first iteration. It picks apple during the second and store it in the item, and being item is being printed. Then again with same with banana, then same with cherry. Python does this three times as we have three items in the list. This is the power of loops. Things about a teacher may marking an attendance. Instead of asking every student's name manually, the teacher simply goes through the attendance register one by one. Python does the same way. It visits every element one by one until the lists end. Now talking about the nested list. A nested list is simply a list inside another list. Think of a classroom. Each student has a name and a marks. Instead of storing everything separately, we can group the related information together. So for that, let me show you as students equals to and again John John, John, comma, his marks, which is 89, comma, and Emma, and and her marks 95. And here, do you notice something? The outer list contains two elements, but each element is itself another list. That's why it's called nested lists. You can also think it as a table. The inner list represents one row, and the first value represents the student names. The second value represents the marks. Now let's access each individually. For that, we need to do this like way. Print students. This is the outer list and this is the inner list. So John is being printed. Now let's print 95. Same in one list and two lists. So for this is 0, this is 1. So for this we have selected 1 and for after that we have selected 0, 1, which is 95. Very simple. Whenever you work with nested list, remember this rule. The first index chooses the row, the second index chooses the column. Exactly like row and column in Excel. Nested lists are very used everywhere. They are used for student records, mark sheets, game boards, spreadsheets, image processing, and many other real world examples. As your program becomes larger, you will see nested lists quite frequently. Now, let's start with tuples. Another topic called tuples. At first glance, tuple may look similar to list. They can also store multiple values. They preserve the order of elements. They also support indexing. So what's make the difference? The only difference is immutability. A tuple cannot be changed after it is created. So basically, let's create our first tuple. Colors equals to red, comma, green, comma, blue. You have noticed something immediately. List uses square bracket, but tuples uses parenthesis or the curvy bracket. Now let's compare a list and a tuple. So for that, We can see lists are mutable. We can modify it. The tuple is immutable. Once created, it cannot be changed. Think of a list like your date of birth. Once it's recorded, it cannot change. A list is, on the other hand, is just like a shopping list. We can add, remove, replace, or whatever we want to do, we can do. The simple analogy helps many beginners to understand the difference. Now, why would anyone use lists? So there are mainly three reasons. First, they are generally faster than lists because Python does not need to manage this. Second, they are using slightly less memory. And finally, they protect important data from accidental modification. Whenever information should remain fixed, a tuple is usually the better choice. Example, GPS coordinates, days of the weeks, months, or mathematical constant. These are all rarely changing values. So they are stored in tuples. That makes sense, na? Now it's time to work with tuples. We will learn the operation that tuple supports, compare them directly with lists, and then build two practical projects to see Python collections in real examples. So for that tuple operations, we are going to access elements, slice them, count them, find indices, and calculate their length. And let's see each one by one. For that, let's go with the coding point equals to 10 comma 20 comma 30 comma 20. Notice the parenthesis. That's how Python knows we are creating a list. This tuple contains four value. Interesting. 20 appears twice. That just like list. Tuple also allows duplicate value. Accessing elements. Suppose we want to write same way. We will access the elements like the lists. Print point and 0. Tuple also start from 0. Now let's go do the slicing of tuples. Print point 1, 2, 3. Python starts at index 1 and stops at index 3. The output becomes 20 and 30. Notice something interesting. The result is also a tuple. Here you can see the result is also a tuple. Now finding the length. So for that, if you want to search how many elements are present in the list, we can simply do it like this. Print length, small letters, length point. You can see 4, 1, 0, 1, 2, 3, 4. Length works with both list and tuples. Then counting values. Suppose we want to know how many values appear, means how many times a value appears. So for that, the same way like list, print point dot count, and the value that we want to know is 20, going with run, and you can see 2 times. So basically 20 that is appeared in 2 times is. Now we can go with finding an index. For that, print point dot index of 30 and clicking on run. You can see again 2 because 0, 1, 2, which is the index of 30. Now you might imagine, if tuples support all three operations, why can't they do the same way as what we need lists? So for explaining that, now let me try modifying the value. For that, let's do with point 0 equals to 50, 65 equals to clicking on run. See, there is error because Python tuples doesn't support um, assignments of new value. No adding, no deleting, no updating. This is the biggest difference between tuples and the lists. Now let's compare both side by side. Let's begin with mutability. Lists are mutable. That means we can add, remove, modify values. Tuples are immutable. Once created, it doesn't need its values stays the same. Next, look at the syntax. List uses square brackets and parentheses, and tuples uses parentheses. Now let's talk about performance. Tuples, since tuples never change, Python optimize them better, make them tuples slightly faster than list. For example, for in small programs, you want to see the much difference, but in large programs, tuples are at better performance because they discuss about memory uses. Tuples generally consume less memory. Think only you don't need to know only this. List are uses extra memory because they need to support adding, removing, modifying values, and tuples doesn't need to overhead that all things. And finally, let's understand when to use each one. Choose a list whenever your data changes frequently. Example include shopping list, attendance records, student marks, or to-do list. Choose a tuple. No, choose a list. And when your data is fixed, choose tuple. Example include GPS coordinates, months of the year, RGB colors, or mathematical constant. These rules are remembered to because if your data changes, you need to use list, and if your data doesn't changes, you need to use tuple. Now going with this some questions. Marks equals to 85, 92, 78, 95, 88. Total equals to sum of marks. I have done this. Then we can go with highest, which is equals to marks, max of marks. Print marks, comma, marks, print total, comma, total, then print highest marks, comma, highest. Let's execute this first. Here Python creates the list marks. Next, it calculates the total marks using the sum of inbuilt function. Then it finds the highest using the max, and finally the output becomes marks list of the marks, then the total, then the highest marks. Notice something powerful here. Instead of calculating everything manually, we have just used a built-in function. Now moving on to next. Shopping cart. So for shopping cart, let's create another simple coding question. For that, we will first go with cart equals to empty cart. Then we'll go with cart dot append. We'll add laptop. Then we'll go with cart dot append mouse. Cart dot remove mouse. After that, print final cart, which is cart. It will not, it will show an error because we are doing small. Now clicking on run, you can see the it's laptop, because we have added mouse and we have removed mouse and we have added laptop, but we have not removed anything. So this is exactly how shopping website manage their items inside a user's carts. Every time you add or remove, the website is performing operations very similar to this at the behind. Now let's build an attendance system using Python list. Imagine you are a teacher taking an attendance class. Instead of writing every student's name manually, you want to store all names in a list and let's process them and makes them process automatically. Let's use the program using. For that, we will go with students equals to Alice, comma Bob, comma Charlie, then print attendance sheet. Then for I, comma students in enumerate students, comma 1, print f I got students, comma present. Clicking on run. Now let's understand every line. List, we have created the list first. Here you have seen same where we have just printing attendance sheet, and after that we have the most interesting line, this one. Here basically you understand everything except this enumerate. So enumerated, normally a for loop gives only the value the student is student. For example, we will be able to print only these three, and here we are using enumerate to do this counting. 1, 2, 3. The counting basically is using the enumerated. It's used basically for the indexing and the value itself, and after that Python counts from 1 instead of 0. So during the execution, Python behaves like first iteration I equals to 1 where student equals to Alice, then I equals to 2 where student equals to Bob, and accordingly. That's how powerful loops and list becomes when they are combined together. Even if you had 1,000 students, the program will work perfectly fine. Now, so going with some common beginners mistake, which are understanding these mistakes today will save you debugging time in the future. Now, moving on to the index out of range one. So basically, index out of range one is basically when we try to access index out of range. Means think of it like this: we have only defined index 0, 1, and 2, but we are trying to access index 3. So it will cause an out of index error. After that, modifying a tuple. A tuple is immutable, so you cannot define a tuple. So basically, this will also cause an error. After that, this append and extend, and append and extend are most common beginner mistakes. So basically, when anyone try to put append two value, when you try to append two values at the same time, it will cause an error because extend is used to append two values at a time, not append. After that, after that, wrong brackets. Using we need to use square bracket for the list and curly bracket and curvy bracket for the tuple. It's fixed. If you do the reverse, then the list becomes tuples and tuple becomes list. Now it's your turn. Pause the video and solve this question. Then compare your solution. Question 1. So basically in this you need to print the sum of all numbers using the sum operator. After that you need to find the max. I have done this using the min. You need to find the max and min. And then in the question 3 you need to reverse a list. So basically in this you can use either dot reverse or either you can use slicing. Here you have to remove duplicates from a list. So for that you can use either dot remove or you can even think of it. After that, here in this question you need to print how many even numbers are existing inside a list. So for that you need to use a for loop and using if conditional. So this is also done. Given a list. And in this one, you need to print name of a student whose marks is above 80. Let me do you the question number 5, in which we need to print even numbers from a list. So for that, we will first do the list. Basically, we will go with the simplest list. Now, for this, we will go with for I in range. This is used for iterating. No, we will not use for I. Nums will use. After that, if nums, no, if I divided by modulus 2 equals to 0, print I, and we will click on run. You can see in this whole list only 2 even numbers are there, 2 and 46, and that are being printed. Now let's quickly revise today's lesson. So today we have learned why collections are needed. Then we have done with what a list is. Then when we have created a list. Then we have done the indexing. After that we have done the negative indexing, then list slicing, then we have done the matching lists. Then after that we have done some methods called append, insert, extend, remove, pop, clear, sort, reverse, count, index, and copy. After that we have gone through the looping through list, then nested list, tuples operation, then the difference between list and tuples, then some questions, and then we have done with the beginner mistakes. If you have understood everything in today's lecture, you have mastered one of the most important data structures in Python. Lists are used almost in every Python application, from web development, data science, automation, AI/ML, and game development, many more. Now, for the next lecture, we are going with sets and dictionaries. So basically, we will understand what sets are, unique elements, and why duplicates are removed. Then we will go with sets operations like union, intersection. After that, we will go with dictionaries, key value pairs, fast data lookup, dictionary methods, nested dictionaries, real world examples, and some project. These are some of the most powerful data structures in Python, and they are actively used in real world software development. Thank you. If you are watching this video, I encourage you to practice every example from today's lesson on your own. Remember, real coding helps when you understand. Reading code helps you understand, but always write a code because you are a programmer. If I will I will see you in the next episode. Until then, keep learning, keep practicing. Thank you for today.